All right, guys, so today we are going to be covering equation word problems. So we know now how to solve one-step equations, we know how to solve two-step equations, but now it is our job to set up an equation, one or two-step equation, in order to solve for a missing value. So just a few reminders, the first being that there are three switcheroo words. So remember, our switcheroo words are from, than, and to. When we see those words, say we have 2x minus 6, and there's a from, than, or to, like less than. Remember, we need to rearrange it to be 6 minus 2x. So we're switching the things we're adding or subtracting. And then a few reminders that words meaning equal to are is, are, was, were, has, have, or will be. When we see those words, we know that we need an equal sign. And remember, since we are writing word problem equations, we are going to have an equal sign since they're for equations. And then just some reminders when we are writing an equation for a word problem. The first step is you want to figure out what x represents, or what's that variable going to be. Like, what is the missing value? What is the question asking? Number 2, writing the equation that fits the problem. And then number 3, solving the equation and including units. So that part's really important. Make sure we're talking about like $6 or 4 dogs, whatever the question is asking for. All right, so number 1 says Gabriel has 16 Pokemon cards, which is 4 less than the number of Pokemon cards Shelby has. How many cards does Shelby have? So remember, the first thing we want to identify is what is the variable in this problem. So usually you can find it where the question is, how many cards does Shelby have? So we're really looking for the number of cards that Shelby has. So that's our variable. We can use an S if we want, or we can still use an X. We can use S for Shelby. So then the second part is to write the equation that fits the problem. So we kind of have to translate these words. Let's see. So let's change our color here. All right, so our equation, Gabriel has. We know that has means equal to. So Gabriel has, we know that's equal, 16 Pokemon cards. Okay, so we know that 16 is equal to the equation of whatever Shelby has. And also it says which is. So when we see the is, we know it's talking about the 16. So which is 4 less than. So remember we have 4, less is minus. Then as a switcheroo word, we'll switch it after, the number of Pokemon cards Shelby has. Remember, this number of Pokemon Shelby has, number of Pokemon cards Shelby has, is my variable. So that is my x. All right, so we have 4 minus x. We don't know how many Shelby has. Now we want to make sure we go back and we do the switcheroo. So we need to switch the two things that we're subtracting. So we would actually write this 16 equals x minus 4. Now from here, you can solve this one-step equation. So what I want you to do is, on your own, solve this one-step equation and write your answer on the side. And when you finish all 4, we'll check them. Okay, but you should be able to solve this. Alrighty, our next one says the yellow taxi cab charges a flat fee of $6 and $3.50 for each mile you drive to take to your destination. If the total was $37.50, how many miles did you drive? Okay, so again, looking for the variable, it says how many miles did you drive? So what is our variable? Well, we're looking for how many miles. So our variable would be miles, the number of miles that we drove. Okay, now, the yellow taxi charges a flat fee of $6. When we talked about setting up expressions, we learned what this flat fee was. A flat fee means it's a one-time thing. We're paying them $6 just basically to get into the cab. It doesn't affect anything. We just have to give them $6 and that's it, just to get into the cab basically. Then they charge us $3.50 for every mile, okay? So we want to think, all right, so it's $6 for the flat fee, okay? That means $6 one time. Anytime there's a flat fee, it's a constant. We don't have a variable attached to it. and meaning plus the $3.50 that they charge us for every mile. Now, if you think about what our variable was representing the number of miles. So we're doing $3.50 once, maybe $3.50 twice, 3 times. We're not sure how many times. So if we don't know how many times we're doing this $3.50 or how many times we're paying it, we have to put a variable with it. So it's $3.50 times the number of miles we drove, which we don't know how many we drove. And what does that all equal? What is the total that they give us in the equation? They say the total was $37.50. Okay, so from here, what I would like you to do, again, this is a two-step equation, so you can solve this. Make sure you get rid of your constant first. So that constant, remember, is that 6. Okay, so we need to get rid of that first. Solve for x, write your answer, box it, make sure you have your units, which would be dollars, and we'll check at the end. Alrighty, so the next one, we have Durbin is 12 years old. We know that is means 12. This is a statement, a fact. We know it's going to be on one side of the equal sign. Then it says this is for less than. Got 4 less than, we know then is a switcheroo word, twice, so 2 times something, Boomer's age. How old is Boomer? I got a little ahead of myself, haven't identified the variable, but we want to know how many years Boomer has. So I'm going to use B for Boomer, and we'll say Boomer's age. We want to know how old Boomer is. So twice Boomer's age would just be 2b. All right? So if we think about my equation, we already said that 12 years old has to go on one side of the equal sign. We know that he is 12, and whatever we're doing with Boomer's age, we're going to solve and put all of the numbers with the 12, but they're not with the 12 yet. So it says this is, again, when it says this is, it's referring to that 12 years old. This is, 12 is. 4 less than, 4 minus, twice Boomer's age. Now, don't forget to go back and rewrite that equation with that less than switcheroo word. So we have 12 equals, and we're just changing the 2 things that we're subtracting. So we're going to take 2b, minus 4. Okay? Again, a 2-step equation. You can certainly solve that. Okay? Solve that on your own. You're going to write what you get in the box on the side. All right, and the last one, we've got Jordan. Jordan bought 4 bags of M&Ms, each with the same amount of M&Ms in each bag, and combines them with 14 single M&Ms in a bowl. If there are a total of 46 M&Ms in the bowl, how many M&Ms were in each bag? So we want to know this time the number of M&Ms in the single bags. So we'll say our variable would be number of M&Ms in one bag, one of those little bags. All right, so my equation, let's see. Jordan bought 4 bags of M&Ms, each with the same amount in each bag, and combines them with 14 single M&Ms. So those 14 single M&Ms don't have anything to do with each bag. So that's going to be my constant. It's going to be my number that stands by itself. And we're combining that with the 4 bags. So we're adding somewhere along the line. So we'll have 4 bags plus the 14 single M&Ms. Now it does say if there are a total of 46 M&Ms, so total is a very good indication that this is all going to equal 46. Total of 46 M&Ms in the bowl, how many M&Ms are in each bag? Well, which number referred to the bag? Was it the 4 or the 14? The 4 refers to the number of bags. So we're going to say 4 times B for bags plus the 14 singles, okay? So again, this is your 4 bags. We don't know how many M&Ms are in each bag, but each bag has the same amount of M&Ms. Plus, there's these 14 single ones in the bag, or in the bowl, excuse me, and they're all equaling 46. So if you wanted to see a little picture, it would be like having 4 bags in the bowl of the M&Ms, and we don't know how many are in each bag, and then the 14 singles, okay? And we know that all of that would equal 46 in the bowl. Okay, so we got to figure out how many are in each bag, and each bag has the same amount. So go ahead and solve this 2-step equation on your own. And then write your answer. And when you finish, get your final answers checked, and then you can flip it over to the back, and there is a answer key at the bottom, okay? These are difficult, but they are so doable, and I know you can do it, okay? Good job. Keep it up.